All right, so we've had some requests for what the heck is going on with ODP 409. Right, so the assignment said 409 is basically like 408. You give it a number, it prints out the square root. Okay, but then you were supposed to do certain error checking for unusual conditions. So, got 5 seconds to warm up. If you say ODP 409 space 25, it should print out a 5. And most people got that working. And let me pull up a Readme. All right, so Readme says if there's not exactly one argument given on the command line, print error. So how do you check that? ODP 409 with no arguments should print error. ODP 409 with 2 arguments should print error. ODP 409 with 3 arguments should print error. If you've got those 3 cases working, pretty sure bet that if I put in 4 arguments, it's going to say error. Okay, unless your code's really kind of random. So that's good check for the first condition. If the argument is given but is not a valid double precision number, print invalid. So ODP 409, blah, blah, blah. I can't even type typos. Here we go. Not a valid number, INV. Right. ODP 409. I just lost my network connection. All right. And then if the argument is a valid real but it's negative, print negative. So ODP 409 space -5, and it should give you negative. And then ODP 409 with a single argument that's a valid double that's not negative should give you the square root. And most people who wrote me and said my code's not working on all the tests, they hadn't tried all of these tests themselves, right? Assess is not for debugging. It's not going to help you. It's going to tell you you've got a bug, but it's not going to tell you where it is. Before you assess, run your code, make sure you've got it passing all of the requirements specified in here, because this is all the stuff that assess is going to do. It's going to try each of those cases in multiple different ways. It's going to try no arguments, 1 argument, 2 arguments, 3 arguments. Okay, so you can go ahead and assess your program, but if it gives you 30 out of 50, right, all it's telling you is that you haven't tested all of these cases in all the possible ways. And your only solution at that point is go back and try these. Now, if you've tried all of these and you're convinced that you've taken care of all these cases and it's not giving you 50 out of 50 or 30 out of 30 or whatever, right, then something different is going on. And it could be you're assessing the wrong program. It could be you're assessing a shell script and it's not executable. Could be one of those weird things, right? But in most cases, what I'm finding is you forgot to try your program with 0 arguments. And then you go ahead and you try ODP 409, enter, and it says seg fault. And right there you know that there's a problem in processing 0 arguments. So then you go into your code and you play computer. Okay, I'm running this with 0 arguments. What is argc equal to? What are argv's entries equal to? What's my first line of code do? What's my second line of code do? And if you do that faithfully, eventually you get to a line of code where you're going to have a seg fault. And you'll throw up on the desk and there's your seg fault. And then you figure out, okay, what should I have done instead? And you change the code and you go back to the beginning, you repeat the whole process. That's debugging. We're going to get better at debugging in this course, and I'm going to introduce you to a debugging tool that's going to make your life a lot easier, but only if you can play computer, right? Only if you can look at your code and sort of know what it's supposed to do and see what it's actually doing. And I've mentioned this before, but this is one of the hardest things about debugging. So you got some code like this. So you've got scraps of codes. You set x equal to 10, you've got a while loop, you say x equals x minus 1. If x equals 0, do some stuff, and it should go through this thing like 10 times, and the last time through it should do whatever this stuff is, right? And you run your program, and it's not doing that. And you can stare at this code for hours, and it looks like it's the right code, right? You've got to forget what you're trying to do. And you got to pretend you're a computer. Computers have no imagination. Computers have no preconceptions. Computers just see and do, right? So x equals 10 semicolon. Pretty sure that somewhere in the computer's brain there's an x, and it's loading a value of 10 into that, right? And there's some while statement, so you do whatever that does. X equals x minus 1 semicolon. Pretty sure you're going to take the value of x, which is 10, subtract 1, that's 9, store it in x, that's what that's going to do. If x equals 0, this is an assignment statement. So when it sees x equals 0, it's going to put a 0 in x. And it's going to say if 0, and 0 is false, so it's not going to do this. And then when I come back up here, my while loop might have been, well, x is bigger than 0. So I check x, it's not bigger than 0, and it exits after one time through the loop. And now you know what the problem is, right? But seeing that as an equal sign instead of a double equal is really hard. Because you wrote it in an if statement, you wrote it as a comparison. Every time you look at it, you see if x is equal to 0, right? And you got to somehow change your lens and see what the computer's seeing, which is if x is assigned to 0, right? And that's the worst error in C to try to catch, right? I can catch it quickly only because I've spent so many hours staring at these things, not seeing it, right? And after enough of that, right, you'll catch it really quickly. But other errors that are less subtle, right? Sticks equals sticks minus num. And up here you said read x for how many sticks you want to take, and then you said sticks equals sticks minus num. And every time you look at this, I'm subtracting the number of sticks that the user picked from the pile of sticks, right? But you're not. You're subtracting some variable that has nothing to do with what the user just typed in, right? And when you look at this, you see read a number, subtract it from sticks. Perfect, right? But the computer, of course, sees read a number, store it in x, subtract this other variable num from the number of sticks. So that's tricky, and it
Leaving off an x.
yeah, or leave those are horrible to find, especially in Bash because you don't get syntax errors. C will at least give you a syntax error when you compile. All right, so 409, the goal was to do all 4 of these steps. So there's some code that'll do it. So we include math.h, we did that in 408, argc, argv. First thing you do, check argc, right? Check if argc is not 2, and if it's not 2, then you don't have command followed by 1 argument, print an error, get out of here, right? Return 0. If argc is exactly 2, now you know argv1 is valid, so scan it into x, and see what scanf returns. If it does not return a 1, that was not a double precision argument. It was a word or something. So print out invalid, get out of here. Otherwise, at this point where we're saying if x is less than 0, we know we had 1 argument, we know it scanned successfully. Let's see if it's negative. If x is less than 0, print negative, you're done. Otherwise, it passed all those tests, take the square root, print it out, and then you're done. So here's what can happen. All right, so I saw code like this. All right, so that works fine. That works fine. That works fine. That works fine.
What about
That
if-
makes it throw up. And the reason that doesn't work is because right here, we're trying to use element 1 from the argv array, and if we run a command with no arguments, element 1 is null. Right, so element 0 of argv is the name of the command, element 1 of the argv array is the first command line argument. No command line argument, no argv bracket 1. Right? So, and I only know that if I check argc, which I'm doing after I've already used argv and generated a seg fault. So the order is critical. I'm messing up my code though. All right, so does that make sense? All right, so other questions on ODP 409? I will probably post a new ODP tomorrow. There's no school on Friday, but you can still turn it in online by 8 o'clock Friday morning. And I won't post an ODP on Friday, but I'll probably post one tomorrow, due on Friday.
Is there an ODB due today?
There's not.
Okay.
All right, so I posted a scary note on Canvas regarding lab groups. So I think 20 people have signed up for lab groups on that sheet where the lab kits are, and the other 45 of you have not, which is a problem because you submit your lab report to a group. Right? If you submit it and you don't belong to a group, it's not going to get graded and assigns you, and it's going to end up being a 0 in Canvas, which you don't want. So if you've already put your name on the sign-up sheet, right, no action is necessary, and your name should be highlighted on that sheet. If you have not put your name on that sign-up sheet, you need to do the following before noon on Friday. Figure out which group you're going to join, okay? Add your name to the sheet, and please use your full name, first name, last name, whatever matches in Canvas so that I can actually like move you into that group. And then send me an email and make the subject CSE 224 lab groups and just tell me which group you joined. And I'll go ahead and add you. Canvas was supposed to let you add yourself to the groups yourself, but I can't figure out how it does that. Right? I checked the box, but there's nothing obvious from the student's perspective of how to add yourself to a group. So I'll add you into a group, but send me an email, okay? With that subject line, and I'll go ahead and move you into a group sometime on Friday. And then over the weekend, you can go ahead and submit. Is that clear? All right, cool. All right, any questions so far with stuff we were talking about yesterday? We were talking about Unix and different Unix commands and file hierarchies. Okay with all of that so far? So let's just touch on some of the basics that you already know probably, but if you want to remove a file, right, just rm and the name of the file. Right, so I had a file called ls, I can remove it. Change mode was the command we were using to change permissions on a file. So if I say ls-l main, right, it's got these first three entries and it says read, write, execute, read, write, execute, read dash execute. So owner and group, that's both Nick, can read this file, write this file, and execute the file. And everybody else can read and execute, but you can't come in and delete it. Okay. So if I say change mode 555 main, and I do an ls-l, so remember how this octal code works? So if you want to know what 555 is, you write each of these digits in binary, and this corresponds to read, write, execute, read, write, execute, read, write, execute, owner, group, world. So you have read permission, no write, and execute, read, no write, execute, right? So this is what an ls-l should look like after I said change mode to 555, and that's what it is. So you can turn these individual bits on or off with change mode, or change mod, by picking a 3 octal digit code. You can also say change mode owner plus read or owner minus execute to not have to do octal, but do the octal, it's good for you. Octal rocks. Yeah,
Once we did the change mode 555, how can we change it back?
change mode again. You can do that as many times as you like. And that's persistent, right? Once you do this, that's the permission on the file. If you don't do anything else, it's going to be like that for eternity. Right? So when you say change mode 755 my script so that you can execute it, you only have to do that once.
When GCC makes an executable, does it run change mode on the executable?
It runs the same thing that change mode runs internally to set those bits, but it's an internal function call. And you can set defaults. So when you create a file, what's the default permission that it gets, and what's the default GCC gives you, and so on and so forth. It's all customizable. Yeah.
Can you change it only for the owner, or?
Only the owner can change the file, or a super user. I think it has to do actually with directory permissions also. But here's something fun, right? I just changed this program so that the owner can read it and then execute it, but can't modify it. So if I try to vi main, it'll tell me this is a read-only file. It's also gibberish, but that's okay. But if I try to write it, it'll say it's read-only, right? But if I put an exclamation mark on my write command, it says write, and it'll override the permissions, if possible. But this won't let me do it because I've actually set those permission codes. And if I try to remove main, it tells me it's write protected, right? It'll go ahead and remove it if I say yes, because it knows I'm the owner, and it knows that I could easily just change the mode back to something writable and then delete it. So RM will actually do that for me. If I say yes, go ahead and remove it. Just type a Y, and now main is gone. So main 2, I've given no permissions to anybody to do anything. So if I try to cat it, it says permission denied. If I try to compile it, it says permission denied. If I try to edit it, permission denied. And of course, if I try to remove it, it's telling me permission denied. But I can change the permissions back. But this can be handy sometimes if you have a file that you really don't want to accidentally change or lose. You can take away your write permission. And then if you accidentally say, you know, I'm frustrated, RM star, it'll like say this file's protected. Do you really want to remove it? And hopefully you say no. And 755 is usually a reasonable protection if you don't mind everybody in the world being able to read a file. If you don't want other people to have access, right, 700, that gives me full access, read, write, execute, no access for anybody else. All right, so we remove files with RM, right? So if it's protected, it won't let me do that. There's a switch you can use. You can say RM-F, which is the force option. And that will just blow by all those protections and delete your file.
Does changemod read the 0 as a string or an integer?
Which 0? Like when I say change mod 0?
Yeah, do you need 0, 0, 0?
Oh, I should have done 0, 0, 0. So I guess it's treating it as an integer. But yeah, you should use 3 digits. Thanks for catching that. Yeah, that's the proper way to do it. So I have this test directory with some files in it, and if I try to remove tester, it'll tell me I can't remove it because it's not a file, it's a directory. So if you want to remove a directory, you use rmdir tester, and if I try to do that, it'll say I can't remove that directory because it's got stuff in it. Right? So you can go inside and you can remove all that stuff, and then you can remove the directory. But again, you can just say remove, don't give me any back talk, just remove it. And oh, didn't expect that. Oh, so if you say -r, so -r says go ahead and recurse into your subdirectories. So it says, I understand there might be directories involved in what I'm asking you to delete, but go ahead and go into all of those subdirectories and delete all of that stuff. So if I say rm-rf, that gets rid of tester, it gets rid of all the files inside it. This is like one of the most dangerous commands available on Linux. Because if you're in your home directory and you say rm-rf star, it'll erase every file in your whole directory tree. And it won't even ask, like, do you really want to do this? It'll just do it. Right? So totally classic, right? You're logged in as root. Yeah.
If we send you executable files like that, will that delete all your files on server?
Yeah. Don't do that. Yeah, because I'll know whose file it was. Now, if you can make it wipe my memory at the same time, you can get away with it. Yeah. But even worse than that, right? So I was in a new job. Everybody's got a story like this. I was in a new job, and this was pre-internet days, but we were working on these machines by a company called BBN, and they were sort of the backbone of the early stage of the internet when it was ARPANET and MILNET. So I'm on a BBN machine, and I had admin access, root access, and I was trying to install some software, right? And somewhere I had done change directory to /, right? And then I went off and I did some other stuff, and I thought I was in my own directory, and I was getting ready to install something, and I wanted a clean slate, and I did, rm-rf star, and I did that from the root directory, right? Well, the root directory is the directory that contains every other directory and every other file in the system, right? So this will remove every file in the system, and since I was the super user, no issue with permissions, right? So I hit enter, and I waited, and about 3 seconds later, it was like, and I hit Control-C, and it was a slow machine. It only deleted about 30 files, but of course they were files at the top of the root. And then you go and you tell someone what you did, and you find a backup tape, and you restore it. So,
Will that eventually remove the RM executable?
yeah, but it's already in memory, so it'll succeed. But then if you try it again, it'll just be like, huh? So if you have your own setup, it's a fun thing to do.
Real fun.
Yeah. All right. So and you can do man rm, and there's information on all of this stuff. So -f is force, ignore non-existent files and arguments, never prompt, and -r is recurse, remove directories and their contents recursively. And Unix kind of like treats you like an adult, right? There's no page of warnings here saying, warning, be very careful when you do this. It's like, it assumes if you decide to take a chainsaw out of your toolbox, you've had proper training in using a chainsaw, right? And
Apart from Gits,
Apart from,
Gets,
yeah.
it says never use this.
Yeah, that one, I'm kind of surprised it says that, but, but yeah, so you can find out about all this stuff. All right, so I got some files left I didn't delete. So we can copy files, right? Copy main2, main22, and main22 is an exact copy of main2, except it's got a newer creation date, which is October 10th, 1025, right, because it was just created, whereas main2 was made 6 days ago. But everything else is the same file size, all that kind of stuff. So CP makes an exact copy. MV says move main2, right, and so now main2, the number 2 is gone, and it's been renamed to this. Right, so MV is basically a rename, CP is a copy. So you can say copy and then remove the old file. That's a little less efficient, but it effectively does the same thing. But when I said move to rename, the creation date of this file is still October 4th. Right, it really just changed the name that I'm using for it. And if we do this I switch, we get these inode numbers in the beginning. That's the actual thing that the operating system cares about. It doesn't care what the name of this file is. It cares where is this file located in this big, think of an array, right? So what entry in the array corresponds to this main2 file, and it's this thing that ends with 650. Now if I move main2 to, something else, this file has exactly the same, what's called the inode number. It's the same index in this list of files that the operating system has. And the name is really just kind of a human convenience. So there's a thing which says when I want the file named that's the file I'm talking about. 4197.650. Now if I copy to 2, and then I remove Haha2 has a totally different inode number, right? Because I created a new file. All right, moving on. So everyone's favorite screen, right? You try to edit a file and you get this weird screen with all these scary looking things on it. Right, you've seen this? Raise your hand if you've seen this. Okay. If you're editing a file and your edit session goes away because your connection drops or something times out, or in this case I just went outside and I killed my edit session, right? What's happening is when you begin editing a file like main3.c, the editor creates a file, you can see it at the top, .main3.c.swap. And it does that to let you know, hey, this file is being edited. Okay? One thing this does is if you're editing a file and somebody else tries to edit the same file, they'll get the same message. And it says, hey, somebody else is currently in an editing session. Are you sure you want to edit it too? Because you don't really want two people making changes to the file at the same time, because you're going to overwrite each other's changes. But for us, usually it happens because we were editing and then something happened, and now we're trying to edit that file again, but it thinks we're still editing it from that first session. So let's just get out of here with a Q. And let's do an ls-al. This is the thing that's causing the issue. Okay, it's a file created by VI. And it actually includes information about recent edits that you've made but haven't saved. So if you made 100 changes to your file and never said :w, and then your network connection dies, those changes are probably recoverable from this file, but say :w as often as you can, and it's a non-issue. Yeah?
And AL for what?
So A says show me, I didn't need the L. A says show all the hidden files as well. So my dot haha and my dot main. So files that start with a dot you don't normally see. If you say dash A, you'll see them. And I could have just done dash A. I didn't need the L.
That's why I do A and send mark M.
Yeah. All right. So what do you do about this? I was editing main3.c and something happened. I tried to edit it, and I got the weird message. I would do a colon Q exclamation mark, get out of there, don't save anything, okay? And cat main3.c. And look at it and see if this is the file that you want. Chances are the current version of the file is the one that you care about, okay? And if that's the case, you can just remove that .swap file, and the problem goes away. But if you look at your file and it's like, no, I found the secret of the universe and I typed it in a comment and it's not in there, right? Now you can try to recover. So you can say vi-recover main3.c, and it'll try to read from that swap file. Now there's nothing in there because I didn't make any changes, but it would hopefully come back, and then you look at this and say, okay, is this the file that I want? If it is, go ahead and save it. If not, get out of here and do something else. Right? Shoot me a note or something. Do some research. So, and then when you're got main3 in the state that you want it, just remove .main3.c.swap. Don't remove main3.c because that's your program, right? But remove the swap file, and then when you vi main3, you won't get that error message. And it's kind of a pain, especially if your connection drops a lot. But it's just something you deal with. All right. So variables. There's a whole, we can define variables. We can say x equals 12. We can say name equals Bill, right? We can assign values to different variables. But there's a whole bunch of variables that already have values. For example, if I say echo $user, it's equal to my username. Okay, I never said user equals Nick. Okay, but Bash set that up for me. Why? Because sometimes your script wants to know who you are. And it can always look at this variable $user. When I change directories, there's an old print working directory which is saved. And I use this command print env, and it shows me all of my variables that have been set up for me. So display shell session ID, that's some magic number. You can play a lottery ticket off of that. Language is English, US, and so on and so forth. So shell is bin bash, right? That's the shell I'm running. We're doing bash in here. And there's this variable called path. And path is the one I want to talk about. Path is a variable that basically has a list of directories separated by colons. And that list of directories is the set of locations where bash will search for a command. If you say haha and it doesn't know what to do with haha, it will look for a file named haha that can be executed. And it looks in these directories and it looks in this order. So first it'll check your current directory dot to see if there's a file named haha. If there isn't, it'll check user local sbin. And if there's nothing in there, it'll check user local bin, and so on and so forth. And if it gets through all these directories and it never found an executable file named haha, then it'll say command not found. But the first directory it looks in that it finds that's the file it'll execute. So user bin is where, this one over here, user bin is where things like ls and gcc and who and all these other commands are stored. So when you type any of those things, it pretty quickly finds those in user bin and it executes it. But notice, right? So in my current directory, I have a file called ls, which is a script. And now if I say ls, the first directory it checks is dot. Right? Dot's whatever your current directory is. And in my current directory, it finds a script called ls, and so it executes that script. Now, if I'm in a different directory and I say ls, it runs the regular ls command. Why? Because there's no ls in dot, right? Nor in here, nor in here, and it has to go all the way over to, I think, /bin before it finds the ls command. And it's the usual ls. So I can do ls224, same thing, right? What's the directory that I'm in? It's my home directory, and there's no ls in there. So it runs the one from bin. And I can say which ls, and it'll tell me it's running bin ls. But if I go into my 224 directory and I say which ls, it's running the one from dot, which is just this unfortunate script. So I can't even see my files in here. Now what if I really want to run the real ls command from here? I can say where is ls, and it tells me, oh yeah, there's an ls in /bin. Maybe that's the one I want to run, so I can type that in. That's my ls. Because I said /bin/ls, it doesn't have to look anywhere, right? Once I start something with a slash, it knows this is telling me where the command is that I want to execute, right? But if I just say ls or hello or haha without a directory in front, it doesn't know what directory it's in. That's when it goes and it checks the path. Does that kind of make sense? So you can customize this however you like. And if I say path equals, dot, and I look at path, that's my whole path. So now if I say GCC, can't find it. Now it's smart enough that it knows GCC should be available, and so it'll actually tell me like it should be available in that directory, but it can't be located because that directory is not in my path. So it's actually like helping me out here, right? If I say who, it's like can't do it, command not found. But bash knows like how the path should be set up. But I've basically kind of like munged myself here because I have no path anymore. And you can do that. So when you log in to the server, or when you start a session like this, so I do these things just by saying Control-Alt-T, and that brings up a bash session. There's a file called .bashrc that always gets executed. This file right here. And so when I first start running bash, all of these commands get executed. And among other things, there's a command that sets my path equal to all of that stuff. Right? It's actually this line that matters. And have an alias for Eclipse because I run Eclipse a lot, so I set up an alias for that. And there's all kinds of things in here. All right. See if I have a network. Hey, I do. So another good command is PS. PS shows you processes. I don't know what it stands for. I always think of it as like process state, but I don't think that's right. Current processes, is it? Who knows? These people were big in pharmaceuticals when this was being developed. So PS shows me processes that I currently have running. So I have two processes right now in this session. I have bash, right? That's where my prompt is coming from and all that. I have a second process. What's my second process? PS, right? Why do I have a PS process running? Because I said PS. And each process has an ID. My bash ID is 37645. My PS command had an ID of 37689, but if I say PS again, that ID is different. Why? Because it's a different PS command. I said PS, it printed out all of this stuff, and then my PS command exited. If I say PS again, a new process gets created to execute that, and it shows me my processes. My bash ID is always the same, though, 37645. But if I exit and I go back in, and I say PS, now I've got a new bash process, different ID. I can say PS-L and I get more information. So user ID is a unique number associated with Nick, right? If you do this, you'll get a different user ID associated with your login. So that's the internal code that the Linux is using to identify you. There's the process ID again. There's also a parent process ID, PPID. The PS command's parent process is 37789. That process is bash. So that's telling you that bash created a process that's executing PS. Which sort of makes sense, because I was in bash, I said PS, enter. Where did the process come from? Bash must have created it. There's other stuff in here that we don't need to worry about, but time will tell you how long it's been running. This used to tell you physically what terminal the person was sitting on when you actually had physical terminals connected to computers. Now they're pseudo terminals, so PTS, and they don't really mean a whole lot. And the state of the bash process is waiting. It's waiting for stuff to happen, right? Most things are waiting. So here's a different machine. And if I look at this machine, there's a process running on it called Java, right? And it's been running for 60 hours, actually 60 days, 9 hours, 19 minutes, 0 seconds. And it started on October 8th. And there's its process ID, and its parent's process ID is this, which is a bash session. So it'll tell you when things started. It'll give you a fair amount of information about what's going on in the system. This is that machine that has 28 cores, so I'm running at like 25 times regular speed, which is how I got 60 days of CPU time since October 8th, because the day happens in like 57 minutes. You can say PS-ELF, that's like everything long, and I don't know what the F is for, and that just shows you like everything that's going on in the system. And there's a lot of stuff going on. Let me hop on the server again. So this is the Linux server and PS-ELF. So user ID, person who owns the process, process ID, parent process ID, priority, when the process was started, how long it's been taken, and what the command is. So root has a whole bunch of processes running on the server right now, starting with its first process, a init, process ID 1. And root owns a bunch of stuff. System daemon has some stuff. And you got to work down. So here's JFlint, and they've got a process running, which is, oh, someone's running Rogue. Good. So T. Holland is running Rogue. Rogue's an awesome little game. But I'm thinking that their session got kicked out because they started that on October 6th. JFlint's running Rogue. That got kicked out on the 4th. Someone's working on their stick program, right? And this information is all out there, right? None of it's protected. Every user can say PS space -ELF, and you can see all this information. So Unix has always been kind of open that way, right? Now you can't manipulate this information unless you are the root user. If you're the root user, you can do things like change these nice settings to make processes go faster or slower. So So you can give people more access to the CPU, or you can restrict it. You can kill processes if you're the super user. But as a regular user, you can only manipulate your own processes. So if I was Jay Flint, I could say kill 8157 and I could kill this process. Right? But as Nick, if I try to do that, it'll say you don't own that process. You're not allowed to kill it. And there's a lot of stuff going on here, right? www-data is the web server. So there's a bunch of processes for that. And you can trace the lineage of these processes. So www-data, all these processes seem to have parent process ID 830H. And 830H is a process owned by root, and it's cut off on the end, but I'm pretty sure that's Apache. But let's see. So 838 is Apache 2, that's the web server. And that was created by process ID 1, and process ID 1 is this process called init, which is the initial process created when you boot a Linux system. So you boot up Linux, it comes with this process init, and init basically creates all the other processes, except for these processes too, which are different. But that's basically the mother of every process on the system now or in the future. When you say PuTTY and you connect to Linux, engrcs.com, there's a process out here called SSHD. It's the secure shell daemon. And I don't want to trace all these, but you talk to the server and the daemon picks up that message and says, oh, somebody's trying to log in, and it'll create a new SSHD process associated with your particular username, and that'll ask you for your username and your password, and it'll authenticate, and if everything's authenticated, it'll look in the file and say, okay, when this person logs in, what shell do they want to use? And for everyone in here, I set the shell up to bash, and so it'll start a new process that runs bash. And then you've got your prompt, and you type in ls, enter, and bash creates a new process that executes ls. And it kind of goes from there. So you can play around with this stuff freely. You can look at this stuff. You can do a PS. I can say bash, and now if I do PS, I've got 2 bashes running. And if I say PS again, I've got 3 bashes running.
Oh.
Yeah. And the PS command I just executed, let me do a PS-L. The PS command I just executed was owned by 38500, that's this process. And this process's parent was 38481, which is this bash. And that process's parent is 83, which is this. And that process's parent is 82. And I'm going to do a quick search here. So 38082 is a process called SSHD Nick. And its parent is 38079. And 38079 is another SSHD process, and its parent is 53538. And that is a process which is the actual SSHD, and that's owned by process ID 1, which is a init. So hierarchy in the file system, starting with the root directory, right? Hierarchy in the process tree, starting with a init, right? And everything creates processes, and those create processes, and so on. Now, if you kill process 1, your machine shuts down, right? But you can't do that unless you're the owner, and the owner is root. But I can kill, let's say kill 9, which says I really want you to kill it. I can kill my bash shell, and I just shut down my connection. Probably ungracefully. But those other bash shells should eventually go away. So towards the end of the course, we'll actually talk about the details of processes and how processes get created. And we'll play around with some of that stuff and see how to actually make processes from other processes. It's really quirky in C, which is pretty fun. All right, I'll see you next time.